All right, it's 19:05, so I think we are good to start. Let's hope everyone is here already. So, hello everybody. Thank you very much for joining us today on this webinar that we are hosting together with our colleagues from Google. In this webinar, we will be presenting Temporian, which is a new Python library that we developed in collaboration between Triolabs and Google. So yeah, before we start, the presentation will last for about 40 minutes, give or take, and we'll use the remaining time of the hour to answer some questions. Any attendee can make questions through the Q&A section on Zoom or the YouTube chat, since we are streaming over there too. If you write a question, please make sure to write the slide number in your question so that we have it for reference when answering it. The slide numbers will be on the bottom right corner on each slide. And yeah, we'll just answer them all together at the end, or as many as we have time to. So before we start, we wanted to give you a little sneak peek of what Temporian is actually capable of, so that you have some idea of what the library's code looks like while we introduce some of its key concepts. Don't worry, we will show many other coding examples in the second half of the presentation. So this is a patient monitor, like those on hospitals. And one of the plots in the monitor is the ECG reading, or the electrocardiogram reading. And next to it is the patient's heart rate, which is computed from the signal on the left. In Temporian, computing this number from the raw ECG signal, which is not trivial, can be done in just a couple of lines of code, which is pretty great. And that's the code right there. We won't go into depth on this example, but we invite you to come back after the presentation and see if you can understand how it works. The code is also available in the heart rate analysis tutorial on the library's documentation, and you will have a link to it at the end too. The agenda for today will be this one. We will give a brief introduction as to who we, the speakers, are, what Triolabs is, and how this project came to be. Then into what Temporian is and what its key features are. After that, we'll talk about how Temporian integrates into the existing ecosystem of machine learning tools and frameworks, and how it works by introducing the event set, which is the main class of the library. Having explained all of this, we'll go into some actual coding examples and use cases on the second half of the presentation. And to wrap up, we'll just point you towards what we think should be your next steps on using Temporian. So let us introduce ourselves. Braulio and I are machine learning engineers at Triolabs. Well, and Gonzalo works with us too at Triolabs. He's the one passing the slide deck. And Mathieu and Richard are research and software engineers at Google, respectively. We four will be the ones talking today. So many of you may know what Triolabs is, but some maybe don't. So let me introduce it very briefly. In a nutshell, we are an AI consulting and services firm, and there's two main things that you need to know about us. The first one is that we are hands-on. So yes, we do consulting and advice, but also have a strong technical team that can go and actually execute AI projects. And the second one is that we are boutique, meaning that we always aim for the highest possible quality of service. We've been doing this for quite some time. We started in 2009, so way before AI was cool, and have always been focused on the US markets. We initially worked for startups in the Bay Area, which was basically the only place in the world where we could find customers at that time. But we from then grew into larger enterprises across the globe and in several industries, as you can see in the slide here. One last thing to note is that we are always prone to participate in open source. And Temporian isn't the first project, the first open source project that comes out of Triolabs. Great. I will skip presenting Google assuming you all know who they are. But one question that you may be thinking right now is, how did we end up actually collaborating on this project with Google? Temporian is basically born out of a shared need, which is a tool to safely, efficiently, and easily handle temporal data. Generic data processing tools, such as pandas, tend to not be well suited for this job. And the user ends up having to write a code that is complex, hard to maintain, prone to failure, and really slow in some cases to get the results that they want. So we all wanted a tool to solve this need. And we wanted this tool to be useful for both short data science projects, but also for processing terabytes and terabytes of data at scale in real time, like Google needs. So yeah, on top of this, we realized that teaming up made a lot of sense, since Google has a lot of expertise working with tons of data very efficiently. And at TrioLabs, forecasting is one of our main areas of expertise. And we know to the bone the issues that come up when working with temporal data. On top of that, we all love open source, as I mentioned. So yeah, it makes sense to create Temporian together. So with that out of the way, what exactly is Temporian? Temporian is an open source Python library for preprocessing and feature engineering of temporal data for machine learning applications. So if we break down this definition, the first thing is that Temporian is open source, so anyone can use it and contribute to it. Temporian is a Python library for data preprocessing and feature engineering. So you could think of something like pandas, but made for temporal data. And the last one is that Temporian works with temporal data and temporal data only. And this allows it to be more simple, more safe, and more efficient than generic preprocessing tools. Some of Temporian's key features are these. We'll go into detail on the first three in the next couple of slides. So let's briefly go over the three on the bottom. The first one, flexible runtime, means that one same Temporian program can be run locally in Python or can be distributed on large data sets using Apache Beam. We will go into detail a bit more on this topic later in the presentation. Interoperability means that Temporian plays nice with other tools in the machine learning ecosystem, such as Pandas or TensorFlow or NumPy or whatever you use. So data can be imported and exported from one library to the other super easily. And that's a very important part of our value proposition. And iterative development means that Temporian allows you to develop your program interactively in your local environment, and then very easily switch to production and scale that same pipeline to production with very few changes. Let's now go over the three on the top a bit more in detail. So unified data processing means that Temporian operates natively on many different forms of temporal data, which means that all forms of temporal data is represented in the same way inside the library. By temporal data, we mean basically any data where records or rows have a timestamp attached to them and where that's important to the problem that you're solving. So it could be multivariate data, it could be time series data, which is the simplest case. It could be time sequences, etc. And that all is represented in Temporian in the same way and treated in the same way. Richard will go over this in detail in a couple of slides. Next, highly optimized means that most of Temporian's core logic is written in C++, and this allows it to handle large amounts of data very efficiently. On top of this, Temporian tracks the underlying graph of operations that is created when a user interacts with the data and allows for the user to perform lazy evaluation if they prefer. And this in turn allows Temporian to perform optimizations on this graph, like TensorFlow and most machine learning frameworks do, which you might have heard of. This leads to us having benchmarked Temporian to be 100 to 1,000 times faster than the same code in NumPy or Pandas on certain tasks. And lastly, Temporian is built to be safe and to prevent the user from making common modeling errors that tend to come up when working with Temporian data. So for example, Temporian makes it nearly impossible to create feature leakage unless the user explicitly wants to do so, and allows the user to programmatically check if a program contains leakage or not. So that's about it for the definition of Temporian and what the value proposition of the library is. I'll now hand it over to Richard to talk about integration.
Thank you, Jan. Hi, I'm Richard, and yes, I will talk about integration. So the way to see Temporian is really as a tool to simplify and improve one crucial step in the machine learning pipeline. And I want to emphasize that Temporian follows the philosophy of doing exactly one task and doing that really well. As a consequence, Temporian strongly values its integrations into the broader ecosystem as a top priority. So let's take a closer look at what that means. So here we see a very simple machine learning pipeline from data to forecast, and that will give us a better understanding of how Temporian fits into the bigger picture. On the left, we have an input that is just raw data, and I'm not going to go into further details on that. Typically, machine learning algorithms struggle with raw temporal data. And it's long been studied that temporal pre-processing can drastically improve model performance. And this is where Temporian comes in. It ingests the raw data, supporting many different types of data, as we'll see later. And then it performs the pre-processing specified by the user. Importantly, the user retains full control over this process. While Temporian is intuitive and super easy to use, there is no magic involved. And the user always controls exactly what is happening. The output of Temporian is pre-processed data that can be fed to a machine learning library. And that machine learning library can create a model, which in turn can generate a forecast. So just to make this absolutely clear, Temporian does the pre-processing. It does not train the model. In fact, Temporian is agnostic to the choice of machine learning library. The goal is to allow users to pick the tool for the job they want. For me, this might be TensorFlow Decision Forest, firstly, because it performs really well on tabular data, such as what is produced by Temporian. And secondly, because TensorFlow Decision Forests and Temporian share a part of its development team. In fact, so many things we learned from developing TensorFlow Decision Forests and from talking to the users of TensorFlow Decision Forests helped us shape Temporian. In summary, Temporian is designed to be one stone in the machine learning ecosystem that is seamlessly integrated with other tools. So you see on this slide some big names. I just want to highlight one of them, which is Apache Beam, because Temporian makes it easy to combine it with Apache Beam, and in doing so, enable temporal feature preprocessing on gigantic amounts of data. Now, let's get to work. We want to show Temporian in action, and there is one concept we have to discuss first, which is the event set. The event set is really the data structure tailor-made for temporal data that is at the heart of Temporian. So what does that mean? The event set is an extremely flexible data structure to represent temporal data. We have a few examples, and we'll look at them from simple to complex. So here you see all the examples, and we start with the simplest one in the upper left corner, the time series. Time series are univariate data that is uniformly sampled. A simple example would be the daily sales in US dollars of a store that is open every day, and we measure it every day at 8 p.m. A very common extension to this is the time sequence. Here, the data is no longer uniformly sampled, so one must store a timestamp along with the measurement. A classic example would be the daily sales in US dollars of a store that is not open every day of the year, being closed on holidays or weekends. And maybe on some days we record the sales at 8 p.m. and on other days we record them at 6 p.m. Going to more complex data, one can have multiple measurements per event, which we call multivariate data. For example, one might be interested in the dollar value of the daily sales, but maybe also in the category of items that sold the most. Temporian's event set starts to show its power here because it allows us to keep measurements of different types, numerical and categorical, side by side in one data structure. And finally, one can also index the data in the event set, which allows us to keep track of multiple time sequences corresponding to different entities. In our previous example, this would correspond to the sales of multiple stores that are somehow related, but still independent time series. The event set is, as you can see, a powerful data structure to express all of these types of data easily and with full user flexibility. Now we want to see this event set in action, and for this I hand over the virtual microphone to Braulio.
Oh, sorry, I was mute. So thanks, Richard. Now I'll talk about some code examples that will be like the building blocks or the basic concepts to generate an intuition that will help us understand better how the library works in code, and also understand the examples that Matthew will be presenting after me. So let's get into it. So the first thing that you need to learn to do in Temporian is how to create an event set. This is the most direct way to create an event set. So you just do tp.eventset and provide the list of timestamps for each of the events. In this case, we have 5 events. And then you provide the feature values for each of the events. So in this case, we have 3 features: the sales unit, unit price, and unit cost. And for each feature, you have the 5 values for each of the events above. So in this example, for example, the first event would be January 1st, 2020, the timestamp, and the features would be sales unit 10, unit price 20, and unit cost 5, and so on to the right, right? Then with that, you are already creating an event set that is this basic, the central structure in Temporian. Then you can just plot that with eventset.plot. And in this case, we are using, let me use an arrow here. We are using the merge argument, and that will plot everything in the same pair of axes, which is not the default, right? Because sometimes we have features that have different magnitudes or very different vertical scales. So in this case, we are keeping things simple, so we are plotting everything together. The last thing to note about this example is that the timestamps are actually made as dates, right? So, but for some kind of signals, for example, think of an audio signal or an electrocardiogram signal, it wouldn't make sense to have date times as the timestamps. So in those cases, we can just use floating point numbers to specify the timestamps. In fact, internally, Temporian just uses floating point numbers for all timestamps. The only difference is that when you have dates, Temporian will enable a flag that says, okay, so this timestamp represents a Unix timestamp, and so it can be interpreted as a date. And in that case, Temporian enables the calendar features, so for example, the day of month, day of week, or wherever, but still internally Temporian just represent dates as floating point numbers. And these floating point numbers are very flexible because you can just, you can represent basically signals that, like in this case, are sampled once per day, but you also can represent signals that are sampled maybe a million samples in 1 single second, 1 microsecond of sampling rate, or 1 nanosecond even, whatever the resolution of the floating point number allows. So this is a very flexible structure. Now we can go to the next slide. So in this case, we are the next thing to learn is how to do arithmetics with the event sets. In this case, we are calculating the profit. So we first select the sales unit features, the sales unit feature, and we multiply that by the unit price minus the cost, and we get the profit for that event, for that timestamp. And then we are just plotting everything, and we see that those results below. So in the top plot, we have like the input features that would be the sales units, unit price, and unit cost. And in the plot below, we see the result of the arithmetic operation, which is the profit, right? So the thing to note here is that in order to do arithmetics between two event sets, this is done event-wise. So you need to have the exact same number of events in both in all the event sets that you are trying to operate with, and also those events must have the exact same timestamps. They must be sampled from the same source, let's say. So if you have different event sets or event sets that have different timestamps for their events, you need to explicitly resample one of them to match the exact same timestamps as the other event set, and then you can multiply them together. This kind of explicit operation to resample that is required is actually a design decision, because we don't want to do any implicit behavior. We don't want to have a hidden behavior, let's say, that would lead to error-prone code. So you need to explicitly resample if you want to multiply or do any arithmetics between different event sets. We can go to the next slide. So the third example I want to show is involves the concept of index that Richard already mentioned. So in this case, we are using two different indexes. We are using the product ID feature, and we tell Temporian to use that feature as an index. And that means that Temporian will separate both all the events related to product ID 1 into one time sequence, and all the events related to product ID 2 into a separate time sequence, and so on. We can have any number of index values, right? So this is very useful, as Richard mentioned, to treat different entities separately, even if those entities share the same features, the exact same nature. So in this case, what we are doing is just defining a window length of 3 days, and we are applying some operators to them. In this case, we are calculating the average profit using a simple moving average with 3 days. Then we rename the feature to average profit. And that is the red smooth line that you can see in the results. And you can see that each of the red smooth lines only follows the blue series related to the product ID that it belongs to. Indexes don't mix with each other, let's say. And then we do the same for the maximum and the minimum profit. And we can see that those results are completely separate for each entity, let's say. So this is an important concept, the concept of index, because we only need to apply once the same pipeline, let's say, of operations, and it will be applied to all the indexes in parallel. So, and finally, the last thing I wanted to show you is the integration with other libraries that Richard also already mentioned. So in this case, this shows how Temporian can be used as part of your already existing code. So if you already have, let's say, a pipeline written in pandas, let's say, to do the pre-processing of your features, and you want to do one specific thing with Temporian, you can start by taking that particular thing, and you can do tp.fromPandas data frame, and that will convert your data frame, your pandas data frame, into a Temporian event set that is to the left. Then you do all your operations with Temporian, whatever operations you need to do, filter out, I don't know, whatever processing you need to do with Temporian. And then you can go back to pandas, to your pandas pipeline, using tp.toPandas and that will convert your event sets into another data frame with your processed features. You can do exactly the same with CSV files. So from CSV and to CSV, we'll convert back and forth into Temporian and to a CSV as well. And that is agnostic of the library, basically, because all libraries support CSV format, right? And finally, we also have for TensorFlow these methods. So from TensorFlow record, and then to TensorFlow record and to TensorFlow dataset. So a typical use case would be that you have your raw data in a CSV file. You use TP from CSV to convert that into a Temporian event set. You process all your, you do all the pre-processing on your data. You filter out outliers. You create the features and all the pre-processing operations that you need to do with Temporian, and then TP to TensorFlow dataset, for example, and you train your TensorFlow model using the features you just created with Temporian. So that is all from me. Now I'll leave you with Matthew with the next couple examples.
Thank you, Braulio. All right. So you've just seen how to import and export data, how to create plots, and how to apply some basic aggregation function. In the next section, I will show you more of the capability of Temporian. Not only I'll show chaining operation, combining of different data source, and index handling. Next slide. Awesome. All right. So at its core, Temporian works by applying simple operation in succession. We call it chaining. And if you're familiar with chaining in Java or JavaScript, this is exactly the same. So on this slide, I show an example with 6 chain operation, which are combined together, and I'll read over them. So on the first line, we select the amount feature from the sales event set. This is operation number 1. On the result of this operation, we apply a moving sum operator with a Windows length of 7 days. This is a weekly sales. Then on the results of this operation, we apply a moving maximum operator with a 28 days windows. This gets us the maximum weekly sales over the last 4 weeks. And then the example continue. We apply a casting, we apply a yearly standing moving standard deviation, and then a renaming operation. So the idea here is that with Temporian and with chaining, you can write relatively complex problem in just a few lines. And what's important here is that those programs are quite easy to read. Next slide. All right. So in real application, the data we receive often come from different sources, which means they are often sampled differently or aggregated differently. For example, in the healthcare demo that we showed at the beginning, there could be multiple monitors connected to the patient. And each of those monitors could provide a different event at different rates and not being synchronized with each other. Or in the sales example that we use so far in this presentation, we might want to aggregate our sales data with data from other databases to make our analysis more powerful. One of the benefits of Temporian is that it makes it very, very easy to combine data from different sources. So let me show you a different way of how this is done. I'll start with a simple example with a glue operator. So the glue operator combines feature with similar sampling. This is an easy one. So in this example, we first compute a revenue for each sale. Here, the revenue is a number of sold items times the price of the item. And then we group this new revenue feature with all the other features already contained in sales using glue. Next slide. Okay, so in this previous example, the data was synchronized, sales and revenue. But what if the data is not synchronized? So in this example, we can use the resample operator. So here we have an holiday event set that tells us about the start and end of holidays. And we want to know for each individual sales, whether or not the sales is during an holiday or not. So what do? We apply the resample operator on the event set holiday based on the sales event set. And then we glue the result together. And we've got an aggregation between two unsynchronized sources. All right, next slide. All right, let's go one step further. We've seen before that Temporian support indexes. So indexes was what you saw in the previous slide when you had different plots showing different store, for example. Indexes are really powerful because they allow different operator to be applied independently for different index value. So this is a great way to control how your data is aggregated. To illustrate these concepts, I'll start with an example without any index. So on this slide, we apply a moving sum on the sales revenue that we computed before. And if we apply the moving sum of that, we obtain the global weekly sales. Simple. Now, next slide. Let's add store as an index with the add index operator just before we apply the moving sum. The result we obtain is the weekly sales for each store, independently and individually. And the result is also indexed by store. Next slide. Index can be even more complex. So for example, we can have an index on both store and client together. So if we have an index on store and client and we apply, let's say, a moving sum, we obtain the weekly sales per client and per store, right? You see how it's being held up. Next slide. But what about cross-index computation? For example, let's say we want to compute the relative weekly sales of each client to each store. In other words, you want to divide the weekly sales per store and client by the weekly sales per store. And yes, you can just do that. You can just do this division. And just to make sure you don't make error, you need to tell Temporian that you will do cross-index computation with the little propagate operator. It's kind of a complex-ish example, but it shows the power of Temporian in aggregation, essentially. All right, next slide. All right, we are done with the example. So to summarize, we showed you a few of the around 80 operators that are currently available in Temporian. And of course, all those operators are well documented and attached to example. And all right, and this is the end of the presentation. So we'll now go to question and try to answer them. But just before that, let me tell you what to do right after this meeting. So the first thing is that you can go on the Google/Temporian GitHub repo. This is pretty much where we hang out. So if you have questions, if you need help, if you have feature requests, if you want to contribute, or if you just want to say hello, you can come here. Then, if you want to learn more about Temporian, you can, of course, check the documentation. If you only want to do one thing, I advise you to read the Getting Started tutorial. It's a nice and short notebook, and after that, you will be able to apply Temporian on your real project. And finally, you can check our post on the TensorFlow blog, where we demonstrate how to connect Temporian and TensorFlow to train machine learning model with augmented data. And on this note, I want to thank you all for your attention, and we can go to the question.
I will read the first question. How does Temporian handle missing or incomplete temporal data?
All right, and you need to tell who can answer it. I'll take the first one and then I'll pass the potato to the next.
Perfect.
All right, so the question is how Temporian handle missing data. So in Temporian, when you have features that are represented with floating point number, and this is a common way to use feature, we treat not a value, NNN, as a missing value. And what it means is that having an NNN is exactly equivalent of removing the event from your dataset. And remember, Temporian support non-uniform sampling. So this is completely capable in the root of Temporian. So let me give you an example of what this can say. Let's say you apply a moving average over a given windows. What Temporian is going to do is to look at all the events in this moving windows and apply the average over all those values. If you have missing value, or if you don't have all the events in these windows, Temporian will only consider those. This feels natural when you apply it, I think. Someone want to ask something, add something?
Let's move to the second one then. Can Temporian be extended with custom data types or operators? And Ian, you want to take this one?
Yeah, I'll take this one. Partially, this is something we want to get better with time. Creating operators is a bit hard at the moment, but for now we do have a map operator that takes a lambda function. So in most cases, if you need some preprocessing done that is not already present in Temporian in our operators, you can use that to do whatever you want on each row of your event set. So yeah, we want to extend this to make it more efficient and to provide other ways for you to do custom operations without losing the efficiency that characterizes Temporian. But at the moment, we do have that operator as a fail-safe.
There's one in the chat from Andres. I will read it. It says, congrats for the library. Thank you very much. Apart from future data leakage protection, scalability, and speed, features which are really nice to have you benchmarked the predictive value of time series feature, which can be generated with Temporian on standard TS datasets versus other known libraries such as TS-Fresh, TLE, Darts, etc., or deep features such as those obtained from trimming deep combinational DNNs or other using some reproducible standard learning evaluation models such as random forest, gradient boosting across standard metrics such different AIUC, Gini, etc. And it says for industrial time series, feature engineering is not really an issue, as it is for more complex problems such as financial time series, where the deterministic component in the signal is minimal relative to their stochastic behavior.
Maybe I can answer that. So the thing to consider here is that Temporian is not intended to be as a to create the predicted model for you. It helps you create your features, but whatever features you feel are valuable or will be valuable for your predictive model. So it's a previous stage to training your model. It doesn't currently include any automatic feature generation. Let's say you have to, if you want to include, for example, lagged sales as a feature or a moving average, you have to do that manually. It's intended to have full control over your preprocessing pipeline and over the features that you create, but you need to specify what are those features. There are other libraries we are aware that help you, like creating some very commonly used features, let's say for forecasting and such. But in our case, we are not intended to solve one particular use case. We are not intended to solve only sales forecasting or only signal processing or only one use case. So we don't try to create automatically features because we are intended to help in very different situations, and that means that there are very different ways to create models in those different situations. I don't know if anyone wants to add something to that.
I do. To add to that, those tend to be really focused on time series data, so uniformly sampled data. So we know there is TS fresh and TS features and such, and those are, as Berlio said, a tool to let you compute a ton of features automatically and then train a model. Temporian doesn't compete between commas with those. I think it's easier and safer to think of Temporian as pandas, but for temporal data. So in the same way that you wouldn't benchmark the features created with pandas against other libraries, it wouldn't really make sense to benchmark features created by Temporian against other libraries, because you are the one defining those features.
Awesome. Here's another one. What kind of error handling and debugging support is provided within Temporian? Who wants to take this? Matthew? Richard? Braulio?
I don't know if Matthew is muted. I can take it. Can you come again with the question?
What kind of error handling and debugging support is provided within Temporian?
Okay. So Temporian tries to minimize user errors in general, either apparent or hidden. It tries to make the user explicit, make the user make explicit as much stuff as it can, versus just trying to guess what the user would like to have happen. That's, again, as probably explained by design. When there are errors, of course, we do our best to show a good error message or a warning and provide an actionable solution for that problem that the user just encountered. And well, I'd say that making plotting very easy and very straightforward is also a great tool for debugging. In temporal data in general, looking at the data and plotting it tends to be a very good way to debug it. So I guess that's as much as I would say.
Cool. Next one. Is there any integrated or preferred visualization framework? For example, Vega, Alter, Plotly, especially interested in mapping temporal datasets to interactive, facet, and multiple linked chart aspects. Who wants to take it?
So the plotting, the integrated plotting library that we use is by default matplotlib. But you can also specify that you want interactive plots by just setting an argument in the plot function that says interactive equals true, and that will generate a plot that you can zoom in and you can like move around and do basically interact with the plot. And for that we use Bokeh, which is another library, a Python library that you need to install in case you want to use interactive plots. I don't know if that was that answers the question. Okay.
Yes. More questions? What if I have a dataset that does not fit in RAM?
Okay, I can try to take this one. All right, so if your data set doesn't fit in RAM, the classical advice is reduce the size of your data set for your development, right? Because you really want it to fit in RAM to have this fast interactive development that is really important in ML. But then once you have developed your Temporian program in RAM on a small dataset, you can run the same program using the Beam backend. Very little changes in your code, and then you can distribute it immediately to tens or even hundreds of machines. So we actually made a benchmark to see actually how good that is. In the benchmark we made, we handled 1 trillion example on 100 machine. Of course, this was almost instantaneous, but just to give an idea that you can really, really scale on things that are well beyond a single machine.
Here's another one. I think we mentioned something, but how is Temporian different from other libraries like TS-Fresh or TS-Features?
Yeah, I partially answered that one before.
Yeah.
But yeah, basically the main thing I'd say is the fact that we allow for data to not be uniformly sampled. On top of that, we do have the concept of indexes. So that allows you to basically store a lot of different multivariate time sequences from different entities inside the same event set and apply the same preprocessing on all of them at the same time, which really does set Temporian apart. So yeah, basically the event set and the flexibility of the event set is the main thing, a part of the efficiency. I don't think these AutoML ones are so geared towards speed rather than good features, as we were talking about before.
Maybe I can add one last point on that.
Yeah, go ahead.
So one of the core ideas of the Temporian is to do only one thing and doing very well. So it's only about feature preprocessing, no forecasting, no anything, just feature preprocessing. But feature preprocessing is just one step in your ML pipeline, right? And you want to do all these other things. So Temporian is also particular in that it's really trying to make sure that you can connect easily with the other tool that exists out there, because it's when you compose the best tool for the best action that you get at the whole the best result. So being super specialized in preprocessing and this nice connection with all the other tools are two, I say, highlight feature of Temporian compared to other libraries.
And we have one more, which is there a way to do some AutoML like feature selection using Temporian or maybe another ML library? Who wants to take it?
I can take that. Currently, we don't have integration with other higher, let's say, higher level libraries, but there could be. So maybe I mean, it would be a separate part of Temporian. It wouldn't be a part of Temporian itself, but there could be a library that is I don't know, but similar to, let's say, what PyTorch lighting is to PyTorch or Keras is to TensorFlow, like a higher level library that uses Temporian in the as the central part to create the features and to suggest to the user how to use Temporian, some Temporian features. But currently, that's not the case. We don't have such a library to automate the creation of features.
That's great. I don't see there are any more questions. You have your last chance to ask a question to the team here. Don't be shy. You can use, there it is. Perfect. So from Wolfram, any details on dealing with live data streams? That would one.
Yeah, probably Matthew wants to answer that.
I can take it. Yes, that's a very good question, actually. So one of the specificity of Temporian, and we didn't talk too much about it, but we talk a lot about it in the documentation, in that in Temporian, everything is a stream, either in reality or in simulation. And so we assume that one event can only depend on other events that appear before this event. And this is a great way to ensure that we don't have feature leakage in all data. Even though the computation is optimized, we have this very strong constraint that you don't have feature leakage and you can only depend on the past. One of the very cool features you obtain with this property is that you can run your program, you can run your Temporian program, both in batch and in streaming, and you guarantee to have exactly the same result. So Temporian program can run in real time. You feed event and you receive the event as soon as the Temporian program can generate it. I'm very excited with this feature, but this is still experimental and not available currently for Temporian user, but we actually hope to release that soon. So yeah, Temporian is very much into streaming.
Another last chance to answer questions in the Q&A section. Okay, if not, I will encourage you to go and see the docs. The documentation of Temporian is something that we are really proud of. It's really well written and has a lot of tutorials and examples. So make sure you check it out, and also to leave us a star in the GitHub repo. That would be great. I want to thank everyone for your questions, for attending this webinar, and also to the speakers. And we'll see you in the next one. There will be a next one for sure.
Thank you.